So when you think of real life problems in math, there's actually a lot of instances where inequalities are a much better representation than an equation itself. I mean, what if I told you that you have up to 20 minutes to take your test? That means you have less than or equal to 20 minutes. It doesn't mean you need to finish your test right exactly at 20 minutes. That would be crazy talk. But this means that you have at least, or up to 20 minutes means that you have less than or equal to. So an inequality would represent that a little better. So let's go ahead and look at what Khan uses for inequalities. And there's a bunch of different examples. That probably wasn't the best example. But let's look at this one. So Rebecca manages a yoga studio that charges each customer a one-time initial fee of $35 and an additional fee of $12 per class taken. Rebecca's goal is for each customer to spend at least $100 at the studio, and she wants to know the minimum number of classes a customer needs to take to meet that goal. So let C represent the number of classes a customer takes. Which inequality describes this scenario? So she's starting with a $35 fee, and it's going to cost $12 per class. And she wants it to be at least, so if you think about it, at least would be greater than or equal to. Because at least means it can equal $100, but she wants it to be possibly more. So we're going to put greater than or equal to. If it was more than, then you just put strictly greater than. So she wants it to be at least $100. So if we look here, that's going to be letter D. And then now we have to solve what is the minimum number of classes a customer can take for Rebecca to meet her goal. So let's go ahead and solve this. So subtract 35. 12C is greater than or equal to 65. Divide by 12. And C is greater than or equal to 65 over 12. Now, is that the answer we can put in there? No, because that's a partial class. If we put it in the calculator, 65 over 12 is 5.41. So 5.41, I doubt she's going to offer a partial class so she can get exactly $100. That means that she's going to need them to do 6 classes to make at least the $100 mark. Let's look at another problem. Alonzo brings $21 to the market to buy eggs and avocados. He gets eggs that cost $2.50. Then he notices that the store only sells avocados in bags of 3 for $5. He wants to buy as many avocados as he can with the remaining money. Let B represent the number of bags of avocados that Alonzo buys. Which inequality describes this scenario? So he brings $21 to the market. That's the most he can spend. He gets eggs that cost $2.50. So let's start with the $2.50. So it's going to cost him $2.50 for the eggs. And then it's $5 for the bags per bag of avocados. Kind of pricey for 3 avocados. And he can spend at most $21. So we're going to say less than or equal to $21. So to look for where that's at, I think it's A. Let me just double check. 2.50 plus 5B is less than or equal to 21. Yes. So let's go ahead and solve for B. I'm going to need the calculator. And then we need to divide by 5. And I get B is less than or equal to 3.7. Now remember, he can't spend more than $21 because that's all he brings to the market. So he can't buy 3.7 bags of avocados. So how many bags of avocados will he need to buy? 3. Now if you answer this question, it says what is the largest number of avocados that he can afford? It's not asking how many bags he can afford, it's asking how many avocados. So there's 3 per bag, so it's a total of 9 avocados. So there's a couple examples, there's a couple more here to the right, but we're going to work through those in class.